Dear students, I will be discussing two important rearrangement reactions in organic photochemistry: Oxa Dipi Methane rearrangement and Aza Dipi Methane rearrangement. First of all, we can discuss Oxa Dipi Methane rearrangement. Beta gamma unsaturated ketones undergo photochemical rearrangement similar to dipymethane rearrangement involving 1,2 acyl migration, 1,2 acyl migration and formation of a three-membered ring. This reaction is called Oxa Dipi Methane rearrangement. You know, it involves the beta gamma unsaturated ketone usually undergo photochemical rearrangement similar to dipymethane rearrangement, and this rearrangement involving 1,2 acyl migration, 1,2 acyl migration and formation of a three-membered ring, that is called Oxa Dipi Methane rearrangement. You can see the mechanism. See this molecule, it is a beta gamma unsaturated ketone. See, it is alpha position of this acyl group, it is alpha and beta, and so this molecule is a beta gamma unsaturated ketone, beta gamma unsaturated ketone, alpha beta gamma, and so it is a beta gamma unsaturated ketone. This on photolysis or photochemical reaction, first of all, a 1,4 biradical is formed. 1,4 biradical is formed. See how this 1,2 biradical is forming. See, on photolysis, homolytic cleavage takes place from this carbonyl group. One electron goes to oxygen while the other goes to carbon. And in this case, this unsaturated carbon-carbon or carbon-carbon double bond, by the homolysis, one electron goes to the first carbon atom while the second electron goes to the second carbon atom, whereby a new bond is formed between this second carbon atom and the fourth carbon atom, or bond formation between C2 and C4 takes place using these radicals, and hence we will get this biradical. It is 1,4 biradical, 1, 2, 3, 4. It is a 1,4 biradical. That is the first stage. And in the second stage, the bond is broken. That is, the 3,4 bond or bond between the third carbon atom and the fourth carbon atom gets homolysis. One electron goes to this third carbon atom while the other goes to the fourth carbon atom. Okay, and thus we can say bond breakage takes place between C3 and C4, leading to the formation of a 1,3 biradical. 1,3 biradical. See, here is the carbonyl group is formed by this carbon and oxygen using the electrons, the free radicals, that is this carbon free radical and oxygen free radical, and hence this acyl group is regenerated. Acyl group is regenerated. Actually, the acyl group in this molecule, original molecule, is attached to third carbon atom, and this gets shifted to second carbon atom, and so acyl group migration takes place from third carbon atom to second carbon atom in this case. That is a 1,2 shift of acyl group takes place. See here, because of this rearrangement, a 1,3 biradical is formed. A 1,3 biradical is formed. It gets closed, or there is bond formation between the third carbon atom and first carbon atom to form a cyclopropane. And so by this formation of bond between carbon 1 and carbon 3, a cyclopropane ring is formed. and the product will be like this. Here actually the acyl group shifts from third carbon atom to second carbon atom, or 1,2 shift of acyl group takes place in this molecule. That is Oxa Dipi Methane rearrangement. You have seen the product of rearrangement is cyclopropyl alkyl or aryl ketone. Cyclopropyl alkyl or aryl ketone. Actually, in this rearrangement, Oxa Dipi Methane rearrangement, acyl group migrates from position first 1 to position 2. It is actually a 1-2 shift on the alkenyl chain, on the alkenyl chain in this rearrangement. Thus, this rearrangement is 1-2 acyl shift. You can see in this molecule, it is the acyl group, it is attached to the first carbon atom in this case. And it gets broken here and shift from this first position to second position. When light is passed through it, homolysis of this bond also takes place, and this carbon becomes a radical and this also becomes a radical. When this bond, carbon-carbon bond, gets homolysis, this carbon become, the first carbon become a radical and this carbon also become a radical. And this acyl group then migrates from this carbon atom to the second carbon atom, second carbon bearing radical. And so a new bond is formed here. Thereby this carbon becomes radical and this carbon also becomes radical, and ring closure takes place to form cyclopropane ring. Okay, that is what is the mechanism involved that you have seen already. Okay, then how this conversion takes place? What is the mechanism of this reaction? This molecule, you can see it is alpha position, beta position, gamma position, and so it is a beta gamma unsaturated ketone. It is a cyclic beta gamma unsaturated ketone. This on homolysis, Oxa Dipi Methane rearrangement takes place to form this product with the formation of a new cyclopropyl ring with the shifting of acyl group from first carbon to the second carbon, or 1-2 acyl shift takes place here also. You can see the mechanism. See, it is beta gamma unsaturated ketone, this molecule. First of all, see, homolysis of this carbon-carbon bond takes place, and thereby this carbon become a radical and this also become radical. Homolysis of carbonyl group also takes place, and so this carbon becomes a radical and this oxygen also become radical, and this carbon radical and this carbon radical makes a cyclopropyl ring, so that you will get this biradical, and this biradical rearranges by the breaking of this carbon-carbon bond. Thereby this carbon oxygen becomes carbonyl group, and a 1,3 biradical is formed. Here a 1,3 biradical is formed. 1, 2, 3, a 1,3 biradical. A cyclopropyl ring is formed by the bond formation between this carbon atom, the first carbon atom, and this third carbon atom. Thereby we will get the product. That is the mechanism involving this conversion, Oxa Dipi Methane rearrangement. Okay, then see the next type of rearrangement, Aza Dipi Methane rearrangement. Aza Dipi Methane rearrangement. When an aldehyde is converted to the imine and irradiated that imine under a sensitized condition, the normal cyclopropyl ring formation takes place. The formation of the cyclopropane by this path is known as Aza Dipi Methane Rearrangement. This aldehyde, see this aldehyde, on treating with this amine, this benzyl amine in presence of an acid, forming this imine. This imine on irradiation, alpha cleavage, see here is alpha beta bond, alpha cleavage takes place here. Alpha cleavage takes place to form these radicals. Okay, then this imine part gets shifted from this first position to second position, as in the Oxa Dipi Methane rearrangement. 1,2 shift takes place. Here this imine part goes to this carbon atom, and so we'll get a 1,3 biradical, 1,3 biradical through 1,2 shift of this imine group from the first carbon atom to the second carbon atom. Okay, and by this 1,2 shift we will get a 1,3 biradical like this, and a new bond is formed between this carbon and this carbon, or carbon, the first carbon and this third carbon in 1,3 biradical, thereby forming a cyclopropane ring, and it is the end product. And this reaction is called Aza Dipi Methane rearrangement. Okay, if you use oxime acetate reacts with this aldehyde, forming imine acetate. This imine acetate, the same type of reaction takes place as in the previous case. Upon irradiation, 1,2 shift of this imine acetate group takes place, and so bond rupture takes place, alpha cleavage takes place here, and this imine acetate group shifts from this first carbon atom to the second carbon atom, forming this cyclopropyl derivative as in the previous case. With this discussion, I conclude this video. Thank you for watching.